Hi everyone, let's talk about the pharmacology of the sedative and hypnotics drugs. Sedative and hypnotics drugs are also called the GABA-like drugs. They are also called the GABA-like drugs because they act on the GABA receptor. For example, the brain 81, which contain lorazepam. Other are ELF, which contain alprazolam. Rivotril, which contain clonazepam. These are sedative and hypnotic drugs. For example, lorazepam, alprazolam, clonazepam, diazepam, etc., etc. Now we will talk about the GABA receptor because the sedative and hypnotic drugs are act on the GABA receptor. What is GABA receptor? GABA receptor are of two types, GABA A and GABA B. GABA A and GABA B. There are two types of GABA receptor, GABA A and GABA B. The GABA A are ionotropic receptor. They are ionotropic, and GABA B are metabotropic receptor. They are ionotropic. When the GABA A receptor are stimulated, the opening of ion channel will occur. Opening of ion channels will occur. And when metabotropic GABA B receptor are stimulated, these are actually, the metabotropic receptor are actually the G-protein couple receptor. G-protein couple receptor. These are GPCR, G-protein couple receptor. When the GABA B receptor are stimulated, the intracellular cascade of reaction will occur. Intracellular cascade of reaction will occur with the stimulation of GABA B receptor or metabotropic receptor. Now we will talk about the structure of the GABA receptor. GABA receptor structure. Actually, the GABA receptor, especially the GABA A receptor, ionotropic receptor, the GABA receptor consists of 5 different polymeric chain. They are consist of 5 different polymeric chain. They consist of 5 different polymeric chain, which consist of 2 alpha chain, 2 beta chain, and 1 gamma chain. For example, this is the structure of the GABA receptor. This is alpha, this is beta, this is alpha, this is beta, and this is gamma. These three polymeric chain will play the most important role in the mechanism of action of sedative and hypnotics. It contains 2 alpha, 2 beta, and 1 gamma. Now we will talk about the pharmacodynamic of the sedative and hypnotics drugs. Pharmacodynamic are the mechanism of action of the sedative and hypnotics towards the body. Pharmacodynamic of sedative and hypnotics. Actually, the sedative and hypnotics will act on the GABA receptor. This is the GABA receptor, this is the chloride 4. These chloride 4 play the most important role in the mechanism of action of sedative and hypnotics. Here the alpha, this is beta, this is alpha, and this is beta, this is gamma. These five are the polymeric chain of GABA receptor. Here in between the alpha and gamma, a specific type of site are present in between this junction, which is called the BZD site. These BZD site provide the attachment site for the benzodiazepine only. Benzodiazepine will attach here. Benzos will attach toward this BZD site, which is present between the alpha and gamma site. In between the alpha and beta, it contains GABA site. These are GABA site. And between the alpha and beta contain a specific type of site, which is called the GABA site, which provide the attachment site for the barbiturates and for the GABA neurotransmitter. When one of the sedative or hypnotics act on the GABA site or BZD site, they will activate the GABA receptor. They will activate the GABA receptor. When the activation of GABA receptor will occur, the chloride ions influx will occur. The chloride ions influx will occur. When the activation of GABA receptor will occur, the chloride force, this is the chloride force which is present between these five polymeric chain. The opening of these four will occur and the chloride ion will increase inside as compared to outside. When the chloride ions enter inside the neuron, for example, this is the neuron. When the concentration of the chloride ion or negative charge increase inside, they will cause the negativity inside of the neuronal cell. Negativity will increase inside the neuron. When the negativity increase inside the neuronal cell, there will be hyperpolarization. Hyperpolarization will occur. When hyperpolarization occur, in hyperpolarization there will be no conduction. No conduction will occur inside the neuronal cell, and there will be no transfer of messages or transfer of impulses from one neuron to another neuron. So these sedative and hypnotic drugs will cause the hypnosis, sedation and anesthesia.